All right. Hello, everyone. Welcome to our training webinar on PyTecplot, where we will be going over getting set up with PyTecplot and some basic scripting. We've done a few of these in the past. A lot of the information will be similar. However, I will point out a few new features and additions as we go today. All right, so on the left there, my name is Gibson Adams. I'm on the support team here at Tecplot, and I'm joined today by Ryan Vandenbos on the right. He will be looking through some of your questions later on. All right, so first we'll take a look at what PyTecplot is and how it might fit in with your Tecplot 360 workflows, as well as some examples of that. We'll take a look at the basic installation process, a short demo of connected mode of PyTecplot in an IDE, and then we'll look at batch mode, the other side of PyTecplot, as well as the environment setup necessary for that, working from the command line and what that looks like. Then we'll take a look at troubleshooting your setup, depending on what platform you're on and what you might be dealing with. Then we'll take a look at batch packs, an alternative form of licensing. Then we'll look at additional resources if you have more questions. And finally, your questions. All right, so first off, what is PyTecplot? Well, PyTecplot is our Python API, which allows you to create scripts directly leveraging the power of Tecplot 360. So Tecplot 360 is our flagship post-processing software. 360 has been depended on for a very long time by people around the world for 2D and 3D plots of dynamic data. It's a tool which allows you to use the 360 engine to interact directly with your data with or without the interface. Finally, it's a way to augment existing capabilities within 360 to accomplish more than you could with the interface alone. All right, so as you heard me say in the last slide, PyTecplot can be used with or without the interface. These are two different flavors. So first, we have connected mode, in which we connect to an open instance of Tecplot 360, and we interact with the data sets that are loaded there directly. And then we have batch mode, which is a way to do automated tasks within Tecplot 360 without actually opening the interface. All right, so why might you use PyTecplot? Well, you may know that Tecplot 360 has its own macro language, which can be used for basic scripting and automation. The macro language has commands for just about everything within the interface, and PyTecplot is no different. However, it's just much easier to learn and read than the macro language that we have. It can also use the complete power of Python and any associated libraries you can think of. So NumPy, Pandas, other data science libraries, you'll see a lot of our scripts leverage these. And you could use these in conjunction with PyTecplot to make anything you could think of in Python. You could edit data as more natural data structures. So, variables as arrays, you can think of these as more natural data structures, and then you can edit them, push them back to 360 for more instant feedback and analysis. You can also use more modern development tools like IDEs, which we'll be looking at today. Overall, this is what we find in support. It's just a faster and more fluid way to automate tasks. It's also easier to troubleshoot problems because of the size of the Python user base. So briefly, we'll look at a few recent examples of how PyTecplot was used to help customers. In the case on screen here, you can see we're looking at our Boston Bay dataset, which is included in our Getting Started guide. So there was a desire here to trace out a path within a 3D dataset. And while 360 offers slices and other derived objects to get that, a more flexible path was required here. We were able to create a PyTecplot script, which takes a line traced out by a user and transforms this into a so-called vertical transect. More info about this one is up on our site in the form of a knowledge base article. Another example comes to us from the New York Yacht Club, American Magic, where engineers were trying to optimize a set of aerodynamic variables across thousands of simulations. They were able to use PyTecplot to output some flow visualization images, which they could then compare later without the need to open each of these simulations in 360 individually. More info on this case is available on our site as well. With that, we'll look at the basic installation requirements here. So first, you will need Tecplot 360 installed, some version of it. Those binaries are necessary for us to use PyTecplot. You will need a 64-bit version of Python. Now, you can download this online, but most machines are going to come equipped with this, so you shouldn't need to worry about that. Installing the PyTecplot library. So here you can use pip for this. The Python-m there is just to direct it to a particular interpreter. The top line there is installing globally, and then that bottom line is installing as a user. And then you will need Tecplot. Tecplot is our Tecplot software maintenance license, so you will need concurrent Tecplot in order to run PyTecplot. All right, so with that, we'll look at a short demo in connected mode in an IDE. Before we do, I'll put down some basic goals that we want to achieve with that. So firstly, we'll open up a fresh file. We'll import the PyTecplot package, and we'll see what that looks like. Then we'll connect this to a running instance of Tecplot 360. We'll get a handle to some common objects, in our case, the data set, the frame, the wing, some variables, and we'll get a handle to the temperature variable in particular, and then we'll work with that. We'll use that temperature variable to get a range. We'll actually make a new variable with that range, and then we're going to send this information back to the interface. And then we'll switch gears and look at recording PyTecplot as a template for scripts. And then we will use that recording to put that back in our original file, and we will export an image and look at the result. All right, so with that, let's jump over here, and you can see I've got Visual Studio Code on the left, and I've got Tecplot 360 2024 R1 on the right. You can see I've got a command line down here. So first thing I'm going to do here, they'll import the Tecplot package in this fresh Python file. And then I need to somehow connect this to my open interface on the right. So the way I'm going to do that is in Tecplot 360. I'm going to go up to scripting, PyTecplot connections. And I'm going to accept connections, which will be toggled off by default. So you see there's a port number here. I'm basically going to be listening on this port. And now that I've toggled that on, I can say tp.session.connect. And let's run this Python file and see the output in the command line down here. And you can see here that I was able to connect to the 360 instance that was running on my machine, localhost, with that port number, and the connection was established. Okay, and you also might have seen the autocomplete kicked in here. This is a nice feature, and this is one of the great things about using an IDE. They usually have some kind of linter, some kind of autocomplete, and we're excited to announce that with PyTecplot 1.7, which we'll be releasing with 2025 R1, that has gained more keywords. So look out for that. So next, taking a look at our Tecplot instance here, we need a way to grab some of these common objects. So first, I'll just get a handle to the frame here that our data set is in. And to do that, I'll say frame, first, I'm going to get I'm going to grab the frame here and say tp dot, and you can see the autocomplete. I don't even need to know the full name of this method. I can just grab active frame there. And let's print that out and see what it looks like. You can see down here, I've got frame 001. So this is just the default name of the first frame. So we've grabbed that. Let's grab the data set within that frame. So I'll say dataset, or ds, is equal to frame dot dataset. It's that easy. Let's print that out and see what that looks like. And you can see here my data set is composed of zones. I've got 2 zones and variables, all of the variables in those zones. So We're interested today in the wing. We're gonna look at the temperature across that wing. So the range of that temperature, sometimes called the thermal stress or the wall heating. So I'm gonna reach into this zone, the wing surface. So to do that, I'm gonna reach into the data set, grab the zone, and this is actually going to bring us to another important distinction between PyTecplot and the Tecplot interface here. So basically in Tecplot, there is no zeroth zone, there is no zeroth variable, right? We start at one because that's a bit more logical for the interface. Now with PyTecplot, we actually follow the Python precedent set, which is being zero indexed. So if I'm working in PyTecplot here, I am going to use the precedent of being zero indexed. So if I want to grab the second zone, I'm going to start at zero, and this is going to be zone one. All right, and let's print out the wing just to see what that looks like. We can see I've got wing surface. I was able to see the type as well as the general shape. So in this case, points, elements, and then some of the connectivity information. Now that I've got that, let's reach in and see if we can get a handle to the temperature variable. So I'm going to reach into the wing zone now, and I need the values of the temperature variable. So I'll say values, and I can enter in the string for the temperature. And I'm actually going to index into that and grab all of the values there. All right, now we need some way to assign a new variable to our interface, to our wing inside the interface. So the way that we can do that is actually pretty simple. I'll say ds dot add variable, and let's call it thermal stress. And now I need to assign this to the values within my wing zone. So instead of getting the values as I did here, I'm instead now going to set the values to my thermal stress variable. And I'm going to need to put some information into this variable. So what we're going to do here is we're going to get the range of that. That shouldn't be too hard to do. I'll get the temp max and the temp min, and that should be the full range. So let's assign this to temp range, and then we're going to assign that to every value in this array. So the way I can do that here quickly is I could say temp range I in range length of our temperature variable. Okay, and with that, let's try to run this. And it kind of looks like nothing has happened here. We didn't print anything out except for that the connection. But let's jump back to our interface and see what happened. So I'm going to go up to data, data set info, and I can see here if I look at the wing surface and I look at my variables, I have this new variable thermal stress, and this is what we expect, right? We see that we have the max minus the min, which in this case is 152.385. And so now we have that new variable in this zone. If I go to another zone, it's unassigned as of now, so we just have zeros there. But we did successfully assign this the values within this zone. So switching gears a little bit, we'll look at another way in which you might start your PyTecplot scripts. Another really common way to use PyTecplot is to simply record your actions in the interface and use this as a template. So this is super useful, especially when you're starting out. I'll go to scripting, record PyTecplot. And now this is actually just going to ask me where I want this file to be once I create it. So I'm going to put it in downloads here. Let's name it export image. That's fine. And we can see here that I've got all these commands while I'm recording. I see that I have a redraw button down here. This is sort of important because if I want to change what's in the frame, the view of what's in the frame, I actually do need to redraw because that counts as a command. And so PyTecplot will record that if I do that action. Unless I do that action, it's not going to redraw the frame for me. Okay, so all we want to do here is export a simple image of the plot. So I'll go to File, I'll go to Export, PNG is fine. It's going to ask me where I want that. Let's just call it a density plot, that's what it is. And I'll put that in that same downloads folder. All right, and so that should be there. Now, how do I access it? Well, I can jump over to my downloads folder, and here I've got that export image script. And it looks like nothing was recorded because I haven't stopped recording. That's right. So jumping back here, I'll stop recording. And now we see that this file has been populated. I'll open that up. And there we have a few different commands. And we have an export image command. Now, this is where I was picking on the screen. So I'll just go ahead and delete that. This is my export image here. So I'm going to grab most of this, and I'm just going to put it into my test script. And that way I'm able to augment the existing script that I have, but use PyTecplot recording to put in any commands that I don't know already. Okay, so that concludes the connected mode example here. Let's just reiterate. So what did we do? Well, we were able to import PyTecplot, the package. We connected this to a running instance of Tecplot 360, got our handles to some common objects. In our case, that was the frame, the data set, the wing, some of the variables, and then we use that information to create a new variable, send that back to the interface for more analysis, and then we recorded ourselves doing some actions with the recording PyTecplot feature, and we use that to export an image. Okay. So we'll jump into the other side of PyTecplot, which is batch mode. Now, this is a way to automate tasks. However, we need to connect to the Tecplot engine without an instance open. So there are a few other considerations we'll need to make. So first, we'll take a look at the environment setup on the next slide. And then we will look at using PyTecplot from the command line, what that looks like. Then we'll look at calling an example PyTecplot script that actually comes with 360. And finally, we'll just use this to export an image as we did in the connected mode demo. So first, looking at the environment setup, the first thing we need to do is basically, we need to set up some kind of environment. This is necessary for 360 to use the 360 engine without opening an instance. So with Windows on the left, you can see these environment variables actually exist within the OS. And in fact, you may not need to edit anything here because with modern 360 installs, a script pointing to the needed environment variables is prepended to your path. However, in case you do need to point to a particular version of 360, the version which is highest in your path is the one that will take precedence. So you can see in the picture on the left, the 360 install that's going to be used, the environment setup that's going to be used here is 2024 R1. What's nice about Windows is that once this is done, there's usually no additional setup that's required. So on the right, on Linux and Mac, the process is slightly different. I will show this today. We will instead point to the environment needed from the command line before we call Python. You can see on screen on the right that you can use the full path each time. That's that first command. Or you can do what I prefer, which is the eval method. This is nice. You only have to load this once. You only have to run that eval command once. And then the environment should be loaded for the duration of that terminal window. Okay, with that information on the setup, let's jump over to the command line and let's see what this actually looks like. So you can see here, I've got the basic command that we had on the other slide. Now, this is reaching into the 2024 R1 install. and the bin directory. And we see here, I've got this Tech360 environment that's going to load all the environment variables necessary. Got dash dash, and then Python, in this case, Python 3. And then I have this dash Intel 64. And this brings up a good point. So I'm on a Mac here today. And because I'm on a Mac with the ARM architecture, that's the Apple Silicon series of chips, right? M1, M2, et cetera, those ones. We actually need to run this in Tecplot's native architecture, which is x86. So the way that we do that is pretty simple. We just do this dash Intel 64, and that invokes the Intel 64 or the x86 Python interpreter. So if I run this, we can see that we've opened an instance of Python here. I'll try to import the Tecplot package, and that seems to have worked. Now let's try a basic command here. So maybe I'll try a new layout. We get a little loading, and then it's done. And now what's important to realize here is that this is not the same instance of Python that I had open in the other window. So you can see here, nothing has changed on this Python or this Tecplot 360 instance. We are actually running this without the interface. This is a totally separate instance. So you probably won't see the program or the app icon light up. But if you look in Task Manager or Activity Monitor, you'll see it there. Okay, so let's exit. And going back here, we're going to do that same thing again, but we're going to run a script this time. So again, I'm reaching into that 2024 R1 installation, and then into the PyTecplot directory, into examples, and then I've got this first example. This hello world example is really just going to open a new layout as we did with the command line, and then it's going to put in a little text box, say hello world, and then it's going to export an image. So let's try to run this. And we could see it seems to have worked. And if we actually look in our downloads folder, we could see this image did successfully show up here. So I'm in the downloads folder, and that's why it popped out right here in this directory. Okay. So with that, we'll take a look at new features. So basically, we have a special announcement here. With the release of 2025 R1, Tecplot 360 is now native on Mac Silicon. So what exactly does this mean for you? Well, if you have a Mac ARM machine, again, that's the M1, M2 series of chips. That's what I'm using here today. And you are using Tecplot 360 2025 R1 or newer, you no longer need to invoke that Intel 64 version of Python as you saw me do today. It should be native. Now, on top of this, there's also probably going to be improvements across the board because, right, we're no longer emulating the x86 architecture. We are running an ARM version of 360 on ARM machines. Now, if you do have an ARM machine and you have not upgraded to 2025 R1 or newer, then you will still need to invoke that Intel 64 interpreter of Python. No problem there. It should work exactly as we did it today. For more info on this, you can see our PyTecplot documentation. We'll show a little bit of that later, but basically all of the information you need is there. All right, so let's go over some of the common points we see in support when running PyTecplot. Looking first here, we've got upgrading to the latest version of PyTecplot. So all this really is saying is this is the first thing we recommend is support, especially with the release of new features with PyTecplot. Upgrading to the latest version might solve whatever issues you're running into. It might have the additional functionality that you need. Running PyTecplot with an Anaconda environment, we've seen some issues with this, although we have a knowledge base article on our site with workarounds for this. On Linux and Mac OS, if you do not run with the Tech360 environment script, then you will run into an error like the one below. So We did not run into this error because we did this successfully today. But if you see an error like this, no need to worry. You just need to run that environment in batch mode. If running on a Linux system with insufficient or no graphics drivers, PyTecplot is going to crash when you try to render images, right? So the solution to this is using software rendering. So you can see there's that -- OS Mesa flag there, and that should solve that issue. And then finally, the Intel version of Python and Python packages are required. So not just Python, but also Python packages are required on Apple Silicon machines. Again, if you're not using 2025 R1 or a newer version. Any other issues that you guys encounter, feel free to contact us at support@tecplot.com. We are, of course, there to help. So here we have batch packs. Now, this is an alternative license type if you have a network license. So when running batch mode, one natural speed up you may think of is splitting work into multiple processes. When running a script, each process that your script uses consumes a seat of a batch license. However, with batch packs, you can use many processes all while only consuming that one seat. So this means that you could potentially have huge speedups in large tasks, all while a colleague can continue to use the interface with a single 360 seat. Again, this is specific to network licenses, so you can reach out to your account manager if you want more info on that. With that, we'll look at a few more points. These are some pieces of documentation that we have. So firstly, the documentation for PyTecplot can be super helpful, even if it's just to glance at for an idea of what objects to use or what those objects might be named. The installation section in particular goes over everything that we cover today. So regardless of what system you're on, you should be able to get PyTecplot up and running. Secondly, the training videos on our site offer a bunch of concrete fundamentals, so you get an idea of how to accomplish any goals you might want to. We also have blogs and knowledge-based articles that we mentioned earlier on our site. These cover most common problems or common use cases, so if you're wondering about a simple workflow, it could already be there. And finally, we have a public repository on GitHub called HandyScripts. Now, this is full of common and not so common use cases that we add to periodically from support. Basically, when we come across a case that might need a more custom solution, sometimes we're able to generalize that solution and then upload it here for anyone to use. So, of course, feel free to clone this and use any of the scripts there. So take advantage of the resources mentioned here to help you get started with PyTecplot. Again, you don't have to be a Python expert to start using PyTecplot and improve your workflows with 360. Refer to the examples that we provided and contact us when you do have any questions along the way. That concludes the demonstration for today. So now, if we have time, we'll look at some questions. Let's see here. Brian, how's that going?
Yeah, we got a couple questions for you, Gibson.
All right.
The first question from a user is, my machine does not have Wi-Fi access. Can I still use PyTecplot?
Yeah, that's a good question. So yeah, instead of using pip to install PyTecplot, sounds like that's what they mean.
Yep.
Yeah, you can actually get PyTecplot directly from the application itself. It's actually included in Tecplot. So the way you can do that, and there's some helpful tips for this online, but you can use pip basically to install locally so you can install PyTecplot as a local package. Yeah, that's totally doable with modern installs of Tecplot 360.
Yeah, and there's more information can be found in the installation guide found in the PyTecplot documentation.
Yeah.
And we got another question for you, Gibson. What is the advantage of using PyTecplot over the macro language? Does it give me a time advantage?
Ooh, yeah. So PyTecplot basically it it might run a little bit slower if you try to use one process, right? But it gives you the ability to spread these things out over many processes. So in that way, it can help speed up your workflows definitely. Um, in general, it might be a bit slower because it's Python in the background, right? Rather than these lower level binaries that are running. So yeah, I would say that in general, it gives you the ability to make your workflows faster. But unless you kind of make those happen, it might be a little bit slower. Yeah. I
Sweet.
don't know if you have anything to
Yeah,
add to that,
no,
Ranj.
that's perfect, Gibson. I'll throw one more question your way, and then for any of those questions that are outstanding, we'll respond to you from our support email. So rest assured your questions will be answered. So one more question for you, Gibson. How can I create non-static videos? So it sounds like it says this person has been using PyTecplot a lot, but most of the videos are exported frame by frame and the camera is static. Is it possible to move the camera
Right.
and the flow time at the same time using PyTecplot?
Yeah, a few things there. Yeah, no, good question. I mean, you can export keyframe animations, so that's an ability that you have, and that's kind of different to. Sounds like they're exporting like time animations. You can export. You have a few export options, so you can look through the PyTecplot documentation there because it sounds like you're exporting a lot of PNGs, or you're exporting sort of like essentially an MP4 or like some kind of video file, but as a lot of PNGs. You can change the way that it's going to perform that export, and that's going to be in the that's going to be in the documentation, yeah, for the specifics of how to change that. Of course, if you have any trouble with that, feel free to reach out to us, and we can look into it further with you for your situation.
For sure, and a good way to think about PyTecplot and the things that are capable is if you can do it in the interface, you can likely do it in PyTecplot, and you just get more access to the data, the raw data.
Right. And that recording feature that we looked at today, that's probably the best way. If you want something particular done and you don't know the commands to get there, that's the best way. Create a template, and then once you have that template of what was recorded, then you can go into the documentation that we provide and you can see like, hey, this is exporting as like the way that this image is being exported was one way, but I actually need it exported, in this other format or in a different way. All right. Yeah. Well, if that's all the questions for now, then we can wrap it up there. Thank you, everyone, for attending.